Hello gang! So today you are asked to apply our new itty bitty tiny particles to a collision problem, the unit that we just left off with. This problem reads that atoms often undergo explosions. Assume a radioactive atom is at rest and releases an alpha particle at a speed of 9.8 times 10 to the 7th meters per second. The atom recoils at a speed of 4.1 times 10 to the 5th meters per second. What is the mass of the particle that was recoiled? And then it asks us to answer in terms of 10 to the negative 24th kilograms. But we'll deal with that at the end. Right now what we need to consider is that we have an explosion problem. Explosions always begin with one object. So here we have an atom. And in the very beginning, this atom is at rest. After the explosion, this is part of your new vocabulary. An alpha particle is a particle that is composed of 2 protons and 2 neutrons. We know the mass of this particle is simply the mass of 2 protons added together plus the mass of 2 neutrons. So we can use that in our problem in a little bit. Our image would look like this. We have the big atom, which is going to recoil, which means that it's going to go backwards. So I'm going to draw an arrow that represents going backwards. And then we have this alpha particle. Remember, the alpha particle is made up of 2 protons, which are positive charges, and 2 neutrons, which are just neutral. And this alpha particle is going to travel in the opposite direction. Since this is an explosion, we know that before the collision occurred, the total momentum of the entire system, since it was at rest, is simply the momentum of this atom, and the atom was at rest, so the momentum is 0. This means that after the explosion, the total momentum must still add up to 0. This means that if the momentum of the atom going backwards was negative 10, then the momentum of the alpha particle going forward would have to be positive 10, so that they add up to 0. That's not really the case here. That was just an example. So let's do some math to figure out what is the momentum of the alpha particle and use it to help us solve the mass of the atom that recoiled. To find the actual momentum of the alpha particle, since it wasn't 10, we're going to use the equation P equals mass times velocity. For the alpha particle, and this little symbol represents alpha in the Greek alphabet, the mass, which we know from a previous quiz question, is 6.6954 times 10 to the negative 27th. We also know the velocity of this alpha particle was 9.8 times 10 to the 7th meters per second. When I put this into my calculator, I want to make sure that I use parentheses so that I keep all of my numbers. So I'm going to do parentheses 6.6954 times 10 raised, so I have to use an exponent, and on my calculator that's x to the y, raised to the negative 27. Notice that this number is very, very, very small, with a lot of zeros, and that's why we write it in scientific notation. But the calculator knows that this is the real digits, and so we're going to take this number and we're going to multiply it by the velocity. Again, I'm going to put everything in parentheses to keep things nice and clean. So my velocity was 9.8 times 10 raised to, which again is x to the y on this particular calculator, the positive 7th power. and then I'm going to hit equals. This is my answer for the momentum of the alpha particle, and it's not in scientific notation, so I'm going to write it in scientific notation. And to do that, you look at the decimal place and you move it so that it comes behind the first non-zero number, and you count the number of times you move the decimal. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And I moved this to the right to make a small number, which means after I put it in scientific notation, I would move it to the left to put it in the correct form. So I'm going to put a negative 19. So the total momentum of my alpha particle was 6.56 times 10 to the negative 19th. Now remember, the momentum of this alpha particle has to be the same as the momentum of this atom, but in the opposite direction. The alpha particle is moving to the right, so my atom is going to be moving to the left. However, the magnitude, or how big the momentum is, needs to be identical. One will just be negative, so it adds to 0. So now let's solve for the mass of the atom. The equation, again, is P equals mv, where P is the momentum of the atom. Remember, it's just going to be the same in magnitude as the alpha particle, but to the left. So I'm going to put negative 6.56 times 10 to the negative 19. And that's going to be equal to the mass of this atom, which I don't know, which is what we're looking for, multiplied by the velocity. And in the problem, it tells us that the velocity is going to be negative, because it's going to the left, 4.1 times 10 raised to the 5th. Now I'm going to divide both sides by this velocity to solve for my mass. Now let's watch me do this in the calculator. I've retained my momentum from the previous problem, so I'm going to leave this here. When I do my division, I'm going to make sure I again use those parentheses so that I'm dividing by the entire number and not just the 4.1. So here's the momentum divided by the velocity, which was 4.1 times 10 exponent to the 5th. Close my exponent, hit equal, and my answer for the mass of my atom is 1.6 times 10 to the negative 24th. Now remember, this is a mass, so it's in kilograms. Now the problem wanted us to rewrite this answer so that we wouldn't have to use the scientific notation. And they want us to divide the answer by 10 to the negative 24th. If I go back to my calculator, and again I divide and put inside parentheses 10 raised to the 24th negative, close my parentheses, I get an answer of 1.6. And that is what I would type into my Canvas quiz.